The next rule we want to look at is the product rule. And the product rule is very useful. We specifically use it when we have two functions that are multiplied together. So if you want to take the derivative of, I'll say, h at x multiplied by g at x, something like this, one function multiplied by another function. And what the rule says is that once you take the derivative of this, what you're going to get is h prime at x, so the derivative of h of x, multiplied by g of x, plus h of x multiplied by the derivative of g of x, right, g prime of x. In other words, it's the derivative of the first function multiplied by the second function unchanged, right, it's the same, plus the first function unchanged multiplied by the derivative of the second function. So the derivative of the first times the second plus the first times the derivative of the second. So it's a pattern that I think once you get your head wrapped around it, it's pretty easy to remember. You just have to practice a little bit. And I'll show you some examples of how we're going to apply this. So let's say, for example, we have something like the following. F of x is equal to x to the 3 multiplied by 2x squared plus 5x to the 4. Now, of course, if you wanted to, you could distribute this, right? You could expand it and then take the derivative using only power rules, but that's not always going to be an option going forward when you have more complex and different types of functions, right? So I want to illustrate how you would use the product rule in this case. So to take the derivative of this, we do the derivative of the first function multiplied by the second function unchanged. So we're going to do the derivative of x cubed, which becomes 3x squared. Multiply that by 2x squared plus 5x to the 4. So that second part, the bracket, stays the same. And then we're going to add the first function, x cubed, same, multiplied by the derivative of the second function. So the second part here, 2x squared, we take the derivative of that, we get 4x. And then 5x to the 4, we get 20x to the 3, right? 4 times 5 is 20. We reduce that 4 by 1 to get 3, just a recap of the power rule, right? And now this would be your final answer. Again, like I said, if you get a question like this, it's absolutely okay to expand it, right? To distribute that x cubed into the bracket, and then you'll have a simple polynomial that you can take the derivative of only using the power rule. You can do that for sure, but that's not always going to be the case. Sometimes these are more complex and you have no choice but to use a product rule at some point, which is why I'm showing you how to do it. So it's the derivative of the first multiplied by the second plus the first times the derivative of the second. That's the pattern you want to follow. Now, like I said before, you could have to use this in combination with the chain rule. So right now this is product rule and power rule, but we can also have examples where you combine the chain rule as well. So 3 rules. So let's say, for example, we have f of x is equal to, and I'll use x squared plus 5x multiplied by 2x to the 3 plus 2x to the 4 to the exponent 2. So just this second bracket is being squared. If we take the derivative of this, what we're going to see is that taking the derivative of the first part is okay, but once we get to the derivative of that second part, that's going to require a chain rule, right? Because this function here is really a function within a larger function, right? It's a polynomial squared. So that will require a chain rule when we get to it. So it can get tricky staying organized with all these rules. So that's really what you want to focus on, is the organization. And if it helps you to underline things with different colors to keep track of what goes where, or maybe you use arrows, whatever you want to use. I'll show you a little bit of what I'm talking about. So derivative, we take the derivative of the first, which is 2x plus 5, right? The x goes away in this case because it's x to the 1. 1 times 5 is 5. That 1 reduces to 0, so that x goes away, and we're just going to have a 5. So keep that in mind. Derivative of the first times the second unchanged. So this part is pretty easy. We just write this out the way that it is. Now the second part, and I'm going to write it down here because I'm going to run out of space, I think, if I do it up there, plus the first unchanged, x squared plus 5x, times the derivative of the second part. So now we got to do the derivative of this second part here. How do I take the derivative of this? Well, it's a chain rule. I got to start with the derivative of the inside and multiply it by the derivative of the whole thing. Now you don't have to do it in that order, even though that's how I showed you to do it in the chain rule video. You can take the derivative of the outside part first and then multiply by the derivative of the inside. It's completely up to you. It's personal preference. So if you want to do it that way, you could say, oh, bring down the 2. You have 2x cubed plus 2x to the 4. And that 2 reduces to a 1, so you don't have to write it. So that's your power rule on the outside. But then you got to multiply by the derivative of the inside. That's the chain rule. And so you'll have 6x squared plus 8x to the 3. So really a lot more brackets than the last example, right? So this part I took the derivative of and put it here. This part stayed unchanged here. That's the first half of the product rule. Then we say plus the first part unchanged, and then the derivative of the second part. This 2 in these two brackets, those are all together the derivative of this second part. Because that 2 comes to the front, that's what this is. It's a power rule. And then the second part here, this is your chain rule. It's the derivative of the inside of that function. So hopefully that made sense to you. Again, it's a lot to keep track of. That's okay. We just have to keep practicing. I'll do one more example. Let's say we have f of x is equal to 2x cubed plus 5x squared plus 10x to the exponent 3 multiplied by 4x squared minus 2. And again, if there's nothing between these brackets, we're talking about multiplication, right? So if it's two functions multiplied together like this, we know we have to use the product rule. So f prime of x is equal to, let's take the derivative of this first part. Well, most generally speaking, it is something to the exponent 3. That's a power rule. So we bring down the 3, 2x cubed plus 5x squared plus 10x, same base, right? But now the exponent is a 2, right? It shrinks by 1. That's your power rule. But the thing on the inside, right, where x would normally be, is not simply x, it's something more complicated. So we have to multiply this by the derivative of the inside. That's the chain rule. So we're going to have 6x squared plus 10x plus 10. That is the derivative of this inside part, right? 3 times 2 is 6. 2 times 5 is 10, right? There's a 1 here. 1 times 10 is also 10. That's how we take that derivative. Now that's for the first part, right? And actually, it's not even the full first part. All we've done here is taken the derivative of this. We have to multiply that by the second part unchanged. So 4x squared minus 2. So now we're half done, right? We did the derivative of the first part times the second part unchanged. Now we're going to add the first part unchanged, so just 2x cubed plus 5x squared plus 10x cubed times the derivative of the second part, which becomes 8x, and that's it. Because 2 times 4 is 8, the 2 reduces to a 1, so this is just x, and you have the constant minus 2. When you take the derivative of a constant, like we talked about before, it becomes 0, it goes away. So that first part was a lot longer than the second part because the derivative we had was more complex than when we took this derivative and simply got 8x, right? So not too bad. Now this is a very long, complicated thing, and the good news is you don't have to expand this and simplify it unless you were asked to, which would be a little bit cruel, so don't worry too much about that. But this is simply useful if we want to find the instantaneous rate of change. So if this is the function you're dealing with, you don't want to graph it and all that kind of stuff. It sounds like a headache. And they're asking you, what's the slope at this particular point? All you do is take this derivative, plug in the value for x, and solve for it, which is a lot of computing on your calculator. That's fair, but it's not a lot of manual labor to figure it out. You could actually punch this into your calculator in one go if you really wanted to. I might do it in several steps just to be safe, because I don't want to make a mistake. But ultimately, this is an exercise in taking the derivative. So if you can get to this point, you should feel pretty good. We'll do another example. This is the last one. I might have said the last one was the last one, but this one here, I'll try to make a little bit different for us. Let's say we have f of x is equal to, and I'll have 2x squared plus 3x multiplied by 5x plus 4x squared minus 3x cubed. And those two functions are in a bracket together, and that bracket is being squared. Well, it's a little different from the previous ones because now the product rule is on the inside, whereas the part that's most on the outside, most generally speaking, is a power rule, right? Most generally speaking, we have a big bracket here, something squared, something to an exponent. That tells me that most generally this is a power rule. On the inside is where we see a product rule, right? So if I want to take the derivative of this, I can start by saying, all right, let's take the derivative of the outside most part, bring down the 2. 2 multiplied by whatever the base is. The base in this case is simply, as it's written there, 2x squared plus 3x, 5x plus 4x squared minus 3x cubed. And the exponent reduces by 1, so it becomes 1, right? 2 minus 1 is 1. And you don't have to write it because it's 1, of course. So that's how we would take the derivative of the power rule. Now, the inside of this, though, is not simply x. It is more complicated, which means we're doing a chain rule, which means we have to multiply. I'm not going to use an x for multiplication because I don't want it to get confused with these x's. I'll just use a dot for multiplication. So we have to multiply this answer we got by the derivative of the inside. Well, the inside is a product rule. So how do we find the derivative of a product rule? Derivative of the first, that would give you 4x plus 3 times the second part unchanged, 5x plus 4x squared minus 3x cubed, plus the first unchanged, 2x squared plus 3x, times the derivative of the second part, which is 5 plus 8x minus 9x squared. And you can see I'm kind of running out of space there. I'm going to fit this bracket in best I can. So just to clear up what I've done here, we have this part here, which is the derivative of the outside part, the whole thing. I brought down the 2 to the front, reduced that exponent to 1, and that's what I got. The base stays the same. Because that base is not x, it's more complicated than x, I have to multiply by the derivative of that inside part. The inside part was a product rule, right? It's 2 parts multiplied together. So I do the derivative of the first part times the second unchanged, plus the derivative, plus the first part unchanged times the derivative of the second part. So quite complicated. You want to make sure you want to leave yourself with enough space to write all this out neatly so your teacher can read it. But other than that, just make sure you don't get too lost. If you need to stop halfway through to kind of take note and keep track of how far you've gotten, kind of recap what you've done so far so you can remind yourself where you are in the process, that's a good thing to do. You'll see me do that throughout these videos. I stop and assess what I've done so far because it's easy to forget where you are when there's so many steps. Okay, so keep trying those examples of the product rule and look out for the next video where we're going to go over the next rule for derivatives.